Alright, year 12, we continue with probability leading to statistics. New chapter, which is chapter 14, which focuses mostly on the binomial distribution with a mix of what we covered before with the expected value variance. Um, it's a particular case of a discrete random variable. We'll see its distribution, and its properties. So let's start with the introduction to the actual distribution. Um, you should have covered that last year. Um, it was called the binomial distribution. Just let me go back. Hold on. I just need to get my. Alright, find my laser pointer. So let's move on. Yep. Okay. So a binomial distribution. It's also called Bernoulli, which is the name, I don't know, the mathematician that was related to it. So the characteristic of a binomial distribution, binomial is 2, so it's in a situation when you only have one success, one failure, so only two possible outcomes. You will also know the number of trials or fixed number. As for example, you roll toss a coin 10 times, that will be 10 will be your number of trial. And to do some calculation, you will need to know the probability of success, which lead to know also the probability of failure. All right, to determine the probability of, let's look at this formula first. So PR of x equals x. So x is what we define as the the random variable, okay, and it will take a specific value that will go from 0 up to the number of trials. We, as it depends on the x values, we can also call p of x, which is a function, discrete function though, and you follow this rule. So you should have seen that before. The first one is a coefficient that is based on the combination. We'll look at how we calculate that. Probability of success to the power of x. The probability of failure to the power of, it's the complementary, it's n minus x. Okay. Alright, I think we have defined everything here. Okay. Again, remember that what m combination of mn means is m is the number of objects or selections, and n is going to be the size that you're going to be rearranging those. Okay, so know that n will be always going from 0 up to m. So here's the formula. Do remember how to calculate a factorial. Alright, a few combinations worth remembering, as they can be calculated without a cas, and it will save you time on the long run. So if you look at the first n equals 0 or n equals m, it always equals to 1. If you go to the next value, instead of 0 you get a 1, or the one below m, so it's m minus 1, it will equal to the number of selection m. An example how to calculate this. So you apply the formula. As you expand each one of them, so this one's going to be a factorial 2. Notice how the factorial 5 over the factorial 3 hasn't done the working out, but let me show you. If you had to do that by hand, is this one is actually the same as that one. And what you do, 1, 2, 3. Hang on. Alright, sorry, let me rephrase that. So what we do here, I want to circle that, and what you're gonna notice, you're gonna cancel out the 2, the 1. What's left is 3 factors, and it's linked to that one, and then you divide by factorial 3. Then you evaluate that, and that gives you a value of 10. Alright, you can also do that on the CAS calculator. In the calc page, you can recall the NCR function, menu 5, 3, and you in brackets you have the 2 values. Okay, so here as an example, they left m and n as variable, so it will give you the formula, and here with 5 and 3 we get the same answer. Alright, strategies and tips when you solve a question that relates to binomial distribution. So have a look at the question. If you need to pause it, do so now. So here are the steps. So the first one is, with the situation with a coin, there's only 2 outcomes, but if it was something that has more that could have more possibilities, then you have to actually choose a success and failure. First, you need to state that it is a binomial distribution. You need to also state that the variable that you are representing, and then list the values for the number of trials as well as the probability of success. Alright, then what you do is you apply the formula for the different values of x. As n is 3, you're going to have values of x going from 0, 1, 2, and 3. And you apply the formula, you simplify, and notice we get the same result as we did in the previous chapter. From that you can build your distribution table if needed. Also, you can do that on the calculator like that. Okay, so here is our distribution table. Whoops. Alright, so where you list the probabilities. Okay, and then from the last exercise, there's things that we can do like expected value, variance, and so on. We're not gonna get to that in this exercise. Alright, second example. So again, pause the video to and try to do the 3 steps that are done in the first example. It's a binomial distribution. Changing the order, so the number of trials is 7, the probability of success is 1/2, and you need to find the probability for a value of 4. The random variable is the same as before. I think that should have come second, is the number of heads. Here is, you apply the formula, you evaluate and simplify. Here in a numerical format you get 27%. Alright, now using a CAS, you'll see that it's much more efficient as you will have a binomial function available to you. The first binomial function is binomial PDF, so it's under those menus. Pop-up menu will come up. You will specify the number of trials, the p-value, and the x-value that you after if necessary, and also I'll show you as well what happens if you leave it blank. And here, for as you leave it blank, what it will list instead is all the probabilities. So n is equal to 3, so the first value is for 0, x equals 1, x equals 2, and the last one is x equals 3. So it will give you the list of all the probabilities, and that you can just put them into your distribution table to complete it. Okay, so what I just said just before, for exercise 2, you use the same menus, so menu 5, and binomial PDF. You enter the values. This time you will set a value of 4 for the x value, and you'll get the same answer as we did by hand. Okay, so have a look at this. Again, the 3 steps. First one is obviously listing that it is a binomial distribution. The second one is the variable, what it is, and then you can get the values for the number of trials and the probability of success. It is a binomial distribution. Again, it's done in a different order, but first that should come is x represents the number of 6s. From that, you can determine what's the probability of being successful to get a 6. So it's going to be a 1 over 6, and n is from the question, so you're rolling 4 times, so n equals 4. You want to find the probability for x equals 3. Hang on, wait, let me come back to this. Alright, I did update the question to at least 3 6s, which is what you have here. So x will be greater or equal to 3. Because n equals 4, it's also equal two probabilities, probability of x equals 3 and probability of x equals 4. You apply the formula respectively, you get those formulas that you will need to simplify and evaluate, and you get the answer using on the CAS calculator. Now, a quicker way using a CAS is you're going to use a different binomial function. Menu 5. This time, just be really careful. You use let me get my laser. It's a CDF. C is for cumulative, so you will define a range, an interval of x values, so a lower value and an upper value. It will calculate all the probabilities in between and do the sum for you. Number of trials, probability of success, the lower value and the upper value, and you get the exact same answer. Oops, sorry, that was it. So we finished with 14a, and I'll see you next time for the rest of the binomial distribution with expected value and variance. See you later.